Because function inverses don't work if a function isn't one-to-one. What does it mean to be one-to-one? A function is one-to-one if every element of the domain corresponds. Anybody? To exactly one element of the range and every element of the range. Anybody? Corresponds to exactly one element of the domain. Every element of the domain corresponds to exactly one element of the range, and every element of the range corresponds to exactly one element of the domain. Got it? Okay, so what does that mean? Okay, we'll use Evelyn and Alondra. Ready? They are basketball players. Right? Way to go. You guys are amazing basketball players, aren't you?
No.
All right. So, this situation, Alondra scored 5 points in a game and Evelyn scored 6. Is that possible?
Yeah.
Yes. Is it possible for Alondra to score 25 points a game and Evelyn to score 0?
No.
Yeah, it is. Is it possible for Evelyn to score 30 points and Alondra to score 30 points? Yes, but that situation is not one-to-one. Although it is a function, it's not a one-to-one function. Because then the question is, if I say, who scored 30 points in the game, we need to know exactly who it was. If I say, well, bring me the person who scored 30 points in the game, you would have to bring me 2 people, wouldn't you? And therefore, it is not one-to-one. So, suppose Alondra, playing against a bunch of second graders, she scores 45 points, and Evelyn scores 2 points, and I say, bring me the person who scored 45 points. Do you know exactly who I'm talking about? Yeah. You do. So that is what it means to be one-to-one. The deal is that if I have something that looks like this, is that a function?
Yeah.
Yes, it is. Is it a one-to-one function?
Yeah.
It is not. And here's why. Watch, Brecken. I appreciate your answer. If I have a height of 1, look at all of the x values that correspond with 1.
Very true.
So if I say, tell me the x value that corresponds with 1, you would say, well, which of the 3 do you want? Do you get my point? So therefore, in order for a function to be one-to-one, it doesn't just need to pass the vertical line test, it also needs to pass the horizontal line test. By the way, all these little bits that you're learning right here, these are things that can pop up on the ACT. So again, seniors, if you're looking to retake the ACT, it might help after you've seen some of these pieces. Juniors, you're definitely ahead of the game because when you take the ACT, you will have covered all the content by having taken this class. So everything will have been exposed to you, and that's definitely an advantage in that way. Okay? So there we have it. If I draw a function that looks like this, say the blue one, that passes both the vertical line test and the horizontal line test. So we'd say that the blue is one-to-one. The red is not one-to-one. And the deal is if we want to find inverses, the function first must be one-to-one. We good? All right. So, function inverses. Let's talk about what it's not. Okay? F inverse is not negative f. No. F inverse is not 1 over f. No, 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 no. That's not what that means. Okay? It doesn't even mean we're taking it to like the -1 power. So what does it mean where we're doing an inverse? This is what it means very simply. The x becomes the y, and the y becomes the x. Or in other words, the domain and the range, they completely swap places. So, suppose I had a very, very boring function. Ready for my boring function? 1, 4. That's my boring function. Suppose I ask you f of 1. That means for an x value of 1, what is the corresponding y value? 4. Suppose I ask you f of 4. That means for an x value of 4, what would the y value be? We don't have anything with an x value of 4, do we? 4 is not in the domain. This boring function only has one input. That is 1. And it has one output. That's it. So we can't do f of 4. Let's check out the inverse. Suppose I ask f inverse of 4. What that means is if I'm given a y value of 4, what would the x value be that corresponds to it? 1. And if I ask f inverse of 1, you might be tempted to say 4, but this is saying if we have a y value of 1, what's the x value? We don't have anything. So you can't do that.
I'm confused.
Which part?
Of the ones that you have crossed off. Can you explain the inverse one again, please?
Yeah, so this means f inverse of 1 means for a y value of 1, what would the x value be? And do we have a point that has a y value of 1? No. So we don't have anything to come up with in that scenario. Okay, that's gone. All right, we'll skip the graphically piece. We'll get to that in a little bit. We'll do an easy example here, and then we'll build from there. Okay, given f of 2 is equal to 3, and f of 1 is 9, and f of 3 is 8, negative 3 is 8, and f of 4 is 5, and f is 1 to 1, that means we can take the inverse, which is really good. Find the following. F inverse of 8. So if the y value is 8, what's the x value? Yeah, you see right here it's going to be negative 3. Hey, f inverse of 3. If the y value is 3, what's the x value? 2. And if the y value is 5, what's the x value? 4. F inverse of 9 would be 1. Yes?
So if it was just a regular function or a regular like f of 3, it's always asking like what is the output if like y is 3?
If we say f of 3, that means we give you an x value, we find a y value. If you're given f inverse, that means given a y value, what is the x value? That's what it means. That's what it means. So again, this isn't times negative 1, it's not 1 over, that's what it means. Let's look at a little bit different scenario here. It says, given that f of x is equal to 3x minus 8, find f inverse of 6. Interesting here. We don't have these specific values here, but the idea is that if there was a y value equal to 6, we want to find the x value, okay? So we know that the y value is 6, we want to find that x value. Anybody got an idea how we might do that? Yeah, just 6 is equal to 3x minus 8. So we make the y value equal to 6, and now we can solve. We add the 8 to get 14 is equal to 3x. We divide by 3, and we get x is equal to 14 thirds. piece of cake upside down. You've been able to find inverse values. What about inverse functions? It turns out that f of x is equal to 2x minus 5. It has an inverse that's an actual function. And it's super easy to find. It's not difficult at all. This says y is equal to 2x minus 5. And in order to find its inverse, all we're going to do is we're going to switch the x and the y values. We'll say x is equal to 2y minus 5. And then we take that and we solve it for y. I add a 5 over to both sides. X plus 5 is equal to 2y. And I divide by 2. And I get y is equal to 1/2 x plus 5 halves. Or in other words, y is equal to x plus 5 divided by 2. You can write it in either scenario that you want. Okay? Go ahead and take out your graphing calculator. I think that this is the coolest part of this piece. I really, really do. I like it a lot. Type in 2x minus 5. And I'm going to zoom 6. We see a line with a slope of 2 and a y-intercept of -5, right? So let's think about that for a second. The y-intercept is -5. So if we were to find the inverse, then instead of the y-intercept being -5, we should have a x-intercept of -5, right? Interesting. It looks like it crosses the x-axis at 2.5. When we find the inverse, it shouldn't have an x-intercept at 2.5. It should have a y-intercept at 2.5. Let's look at what we get if we type in the other function right next to it. I'll type in 1/2 x or 0.5x. I can't remember. Was it plus 2.5? Yeah. Yep. So plus 2.5. And I press graph. Oh, hey. That's kind of cool, isn't it? Like, look, -5, -5. 2.5, 2.5. See how they just switched spots? In fact, what's really, really cool about this is inverses. Y and x just switch spots, right? So watch what happens if I do this last piece. I'm going to say y is equal to x. And what happens when we graph y equals x? What does y equals x do to those two functions? Splits them perfectly, doesn't it? Yeah. In fact, you know that one function is the inverse of the other if they are reflected over the line y equals x. That's pretty cool because I can always check my answer by doing that then and be confident that I did it correctly. And that leads us into other stuff that we're going to use in this class eventually, that reflection process, especially when we get to logarithms. I can't tell you enough. It's so important that you understand this piece that we just did for when we get to logarithms and exponentials later on because they involve inverse functions. That's why we're doing this now before that time. I like it. Okay, so it says right up here, it says that graphically they are reflected over the line y is equal to x. And that's one way we can determine that they are in fact inverses. Let's find the inverse for letter B. Some people struggle with this one, but fortunately you guys are super smart, so it's no big deal. We have y is equal to 2 minus x over 3x minus 4. So if I want to find the inverse, what should I do? Yep, switch them. So I get x over 1 is equal to 2 minus y over 3y minus 4. Why did I write it as x over 1, do you think? Yeah, I got a fraction. If I have a fraction equal to a fraction, I'm going to cross multiply. So I've got x times 3y is 3xy. I've got x times -4 is -4x. I got 1 times 2 is 2. which is Portuguese for 2, and 1 times negative y is negative y. I'm trying to solve for y, but the problem with solving for y is that there's how many? 2. What do I do? Oh, did we do that once before?
Yeah.
You mean your teacher thought about the skill that you're going to need to have at this time and prepared you back in Unit 1? Yes, we did. We're going to gather all the y's on one side. 3xy plus y is equal to 2 plus 4x. Evelyn is 100% correct. She has excellent recall in her brain. Good for her. She's super smart. Now that she has all the y's on one side, what will she do? Factor that y out, that little tricky thing. 3x plus 1 is equal to 2 plus 4x. And now we divide, and we get y is equal to 2 plus 4x divided by 3x plus 1. And that's my inverse. Turn to the person next to you. How are you feeling about this right now? Scared? Excited? Where are you at? Go.
Because you divide that, then you're just left with y. What if you have like y squared?
Okay, I'm going to change this one. Instead of the 2 minus 3x cubed, I'm going to change it to f of x equal to 8 minus x cubed. Okay? I don't like that other example. I'm going to change it. That's the beauty of being a teacher. You change your examples if you want. You don't get your own parking spot, but you do get a chair. You know what I mean? Yeah. All right, so I write it as y is equal to 8 minus x cubed. And if I want to find the inverse, what do I do? X equals 8 minus y cubed. I have to solve for y. What should I do first? Should subtract the 8. So I got x minus 8 is equal to negative y cubed. Now what? Divide by the negative. So I get a positive 8 minus x is equal to y cubed. And then? Not square root, but? Cube root. Yeah, or did you say third root?
Yeah.
Oh, okay. Sorry, Ebby. And I get y is equal to the cubed root of 8 minus x. Do you remember in the last unit kind of graphing these types of things? So you could literally sketch them by hand to see if they look like reflections of each other. And I have to do it. I can't resist. I just think that this is the most fun part. So I'm going to quick do it. I'm going to do 8 minus x cubed. And then the other one was the cubed root. Cubed root is in my math part here. I go cubed root. And it's is it 8 minus x. And I'm going to look and see if they, oh, wow, isn't that cool? Like they're perfectly reflected, aren't they? Yeah. We know we did it right. Pretty cool. I love how math can just confirm itself. You know, it's neat that way. Okay. Next one. The others are super simple. This is the last one you really got to focus on, and this is probably the problem on the test that people get wrong the most often. Okay? So if you want that perfect grade on the test, this is where you're going to have to lean into, but I do get the IDK in this scenario. Okay? Alondra, you're going to have to wake John up. He's getting a little tired. He's been out late. F of x is equal to 4 plus the root of x plus 1. I'm going to start with a little bit of exploration here because I can, but I'm going to draw the graph of 4 plus the root of x plus 1. I always think it's great to think about the graph before I do anything. Don't have to, but I like in this scenario. What does the square root function look like if you were to graph it? Yeah, just kind of that thing right off to the side, but it's going to be shifted Up 4 and left 1, right? So I'm going to go back 1 and up 1, 2, 3, 4. Everybody agree with that? Yeah. So like this one right here actually starts at -1, 4. Anybody want to guess where the inverse is going to start at? 4, -1, right? It should start at 4, -1. Like we can make that prediction right away. So
attention students with the last name beginning I through L, please report to the gym for pictures at this time. Again, students I through L to the gym for pictures.
So that's where I would like to be, okay? Let's see how it works out. Y is equal to 4 plus the root of x plus 1. If I want to find the inverse, I switch the x and the y values. X is equal to 4 plus the root of y plus 1. How am I going to solve for y? I'm going to have to get rid of the square root. Before I get rid of the square root, I first need to subtract that 4. X minus 4 is equal to the root of y plus 1. Do I get rid of the 1 or the square root now? How do I get rid of the square root? Square both sides. X minus 4 quantity squared is equal to y plus 1. I'm not going to multiply it out because I'm going to leave it in vertex form. That way it's really easy to graph. And now I get to subtract 1. X minus 4 quantity squared minus 1 is equal to y. Well, that's a parabola that's in vertex form, right? And what's the vertex? What's the horizontal shift? Right 4 and down 1. Is that where we want to be? Yeah. Right now you're like, again, I don't get what the big deal is. Like, why is this difficult? If you take the black one and reflect it over the line y equals x, you don't get the green one, do you? Everybody see we have a problem? In fact, what part of the green one would you get if you were to reflect it? The right side, right? So what we have to do is we have to get rid of the left side. And it's not difficult to do. All we have to state here is that in order to get rid of the left side, we have to state that the domain is going to be from 4 to infinity. So on the test, if you get in this type of situation where you square both sides, you come up with a parabola, something in your brain has to say, the parabola ain't 1 to 1. I'm going to have to restrict the domain so that way I only have the green, I don't have the red. Just the green, not the red.
Again, I have a question. So the parabola is like the only part. Okay. Would there ever be another situation that we would have to take the aside or just
Anytime it's not 1 to 1, but I think I've restricted all the situations so they're just a parabola. But I keep it nice and straightforward for you.
Thank you.
Yep. Okay, I'll flip back. This is our last part. How do we test to see if two functions are inverses of each other? For example, we have Alondra and we have Evie. Are they inverses of each other? I don't know. How would we test? Well, here's how you test to see if something's an inverse of another one. You take F composed of G, and if you get X, then they are inverses. But because because composition is not commutative, you also have to check G of F. If they both give you a resulting X, then they are inverses of each other. If you don't get a resulting X, then they are not inverses of each other. So, look at example 4. It says, use the property of inverses to determine if these are inverses of each other. If it says this, use the property of inverses to determine if they are inverses of each other. You don't switch X and Y, you do composition. So I'm going to compose F of G, and I'm going to compose G of F. Here's where those of you who have sloppy handwriting and those of you who like to take shortcuts on the test, this will cost you, I will take off points. I have to be able to see your work, and I'll show you exactly what I'm talking about. F of G, that means I take this and I dump it in for X. And I get 3 times the quantity X plus 5 over 3 minus 5. Let's look to see if something simplifies. Can I cancel out this positive 5 and negative 5 right now? Not yet. What do I have to cancel out first? The 3's, right? 3 times and divided by 3. Are we agree that the 3's are going to cancel? So this will then produce for me X plus 5 minus 5. Can I now cancel the 5's? Yes. And so it just produces X. Is that what I wanted? Without a doubt. I want to see this step that you knew to cancel the 3's and not cancel the 5's right away. Look at what we're going to do with the next one. We're going to go ahead and switch. We're going to now do G of F. That means I take F and I plug it in right here. I really like to see those parentheses so I know what you're plugging in. Plus 5 divided by 3. Can I cancel off the 3's right away? No. Can I cancel the 5's? Yes, you can. And so you get 3x over 3. Can I now reduce the 3's? Yes. We got x in both situations. So, are they inverses of each other?
Yeah.
They are inverses of each other. Can I show you what people do on the test that I do not give full credit for? This is what I get from people on the test, and I will not stand for this, okay? I'm demanding more from you. I'm sorry if that seems mean, but I am. People do this. That doesn't tell me you know what you're doing. That just tells me you know you're supposed to come up with X. You get my point?
Yeah.
Tell the person next to you if you possibly may have done that if I wouldn't have warned you. Go. If you want to take a guess, if boys or girls are more likely to do that? Boys are more likely to do that. Boys, you're warned. Okay? Next one. This one is critical for people. Okay, I put in a fraction one. People struggle with fractions. We talked about that before. I'm going to go ahead and take this and put it right there. So that should be a 1 over, and then I have a 1 over x minus 2, and I have a plus 2 on the end. Notice that they are all underneath the division sign. What reduces right away? The 2's. And so I get 1 over x. Hey, I don't divide fractions, I. And so if I multiply by the reciprocal, I just get x. That's good news for us, right? I want to see if you can do G of F. Try to write it in the correct places, in the right form, and see what cancels first. So this is like 3 over 1, right? So the 3's will reduce. Right?
What the?
Because it's 1 over x plus 2, so you have to put that there. And then you multiply
Well, this he wrote it because it
so first, and then
the ones came to.
gotta get it right, no shortcuts.
Okay? This is what I should see. I should see 1 over x plus 2. The minus 2 is not underneath the division sign. Okay? Can I cancel these 2's right away? No, I first must take this reciprocal. That's what this means. 1 over something means the reciprocal. And what's the reciprocal of 1 over x plus 2? So I have x plus 2 minus 2. And now the plus 2 and the minus 2 reduce, and I get just x. So yes, they are inverses. We're almost done. You're doing a great job. Letter C, f of x equals 4x squared for x greater than or equal to 0. Everybody freaks out when they see that. What shape does 4x squared make? A parabola. Well, if I go for just x, is a parabola 1 to 1? No, but if I cut off that half, is it now 1 to 1? So you don't have to really do anything about it. It's just stating, hey, we're just using this half of the parabola, okay? So we're going to see if these are, in fact, inverses. This one goes really nice. F of g, and I take g and plug it in for x right there. 4 times the quantity, root of x over 2 squared. What should I do first? Square it. And what do you get if you square it? X over 4. And what's 4 times x over 4? X. You try g of f. We're good with that? All right, last one.
Oh, wait, I have a question?
Yeah.
Oh, yeah, because it's screwed. Never mind.
Okay. Last one, f of g. I take the 1 over x cubed, I put in the bottom, and I get 1 over x cubed, that quantity cubed. What do I do first? I cube the bottom, right? What do you get if you cube the bottom?
1 over x.
1 over x to the 9th. And what's the reciprocal of 1 over x to the 9th? X to the 9th. Did we get x?
No.
No. They are not inverses of each other. And that's that. Congratulations. Good job. You made it through. We have a test next week, Wednesday. You're going to do amazing. I'll get you a study guide tomorrow. Juniors, if you want to pop in right away tomorrow to get the study guide, I can give it to you before you head on down to the career exploration piece. And we'll go from there.